Hi, welcome to Autonomous Mission Code interview that I and my friend Eren wrote for Metrobot 2022 Autopilot competition. Let's see how our code works in simulation. Let's start with mission explanations. Mission is composed of two parts. First, you got to draw a cube with 5-meter long edges. Then you will have to draw a triangle while looking at its center. Both missions don't include any computer vision element but contain a great amount of positioning and orienting practices, which is necessary for a computer vision mission to succeed. For simulation and real-time execution environments, we used PX4 environment because it was necessary for computation. It was a great open-source autopilot software. Our code is written in a way that with slight modification, different environments could be used, such as Autopilot, AirSim, and etc. Python used as programming language with async programming, and MavSDK Python library is used for controlling drone movement and gathering information of the drone. As ground control station and 2D visualization tool, QGround control is used, while for 3D visualization, Gazebo is used. Let's start with code explanation. Algorithm for mission 1 could be explained much more easier on a unit cube, so we will explain it by that. With 16 steps, 12 edges of the cube could be followed. To get that trajectory, required positions with correct sequence are given in table. Multiplying each position with required length of cube will create the desired trajectory. Then adding an offset to z dimension will create our mission waypoint list with 0 degrees on net. By basic trigonometric calculation, each point on x degrees to net could be found. This way, any plane could be used for the mission. For mission 2, steps are pretty much the same with first mission. First, find positions of each vertex and center point in net. Then we can create a list of waypoints that will form the edges of triangle. After that, with simple trigonometry, heading could be computed for each position. By looping through lists, second mission could be also accomplished. Async I/O library is important because we are using async programming and using input-output operations. Also, since we will use algebra and time skips, we also import the math and time libraries. And at last, MySDK F-board library is important because we will use off-board flight mode to control the drone, which is a feature of PX4 autopilot software. Main script will run function until it's ended, so let's jump there. For a clear explanation, the black box approach will be used for functions, but detailed information is given inside the comments. Code starts with variable declarations for each mission. We will declare angle with net, select the plane we will work with. Mission positions are in 0 degrees at start, then we will create a new mission positions list according to our plane by using mission list maker. Now we have a list that has proper positions to execute our code in the required plane. Then second mission variables are declared. Again, there are points of the triangle for 0 degrees mission which will be converted to proper positions for our plane. This approach is selected because by changing one parameter, which is rotation degree, we can achieve same mission for any plane. At least, the positions for lines of triangle are created and variable declarations are ended here. Drone arms and takes off. Then flight mode is getting changed to off-board. First mission is accomplished by going to each location in the mission list. After each point is reached, we can start mission 2. Second mission is accomplished pretty similar to mission 1 except heating of the drum is being changed with each loop. Calculation is made by calculating angle between current position and center point. When second mission is accomplished, drone goes to return mode and returns to launch, then disarms. Hopefully the interview was useful for you. If you have any questions, you can ask your questions to alibergserin.berg@gmail.com.